So good evening, my name is Suhail. I work with the Nature Conservation Foundation and the National Center for Biological Sciences. And I'll give you a very, very brief introduction to Dr. John Fitzpatrick, who will be speaking. Dr. Fitzpatrick started his career a long time ago. When he began, he worked primarily on neotropical birds in Peru, and in particular in a part of Peru that has extreme diversity. And I learned, a bit to my shock actually, that this one area of Peru, Manu National Park, and maybe immediately surrounding, has nearly 1,000 species of birds just within that. Sorry? More than 1,000 species of birds. That's almost as much as all of India in one national park. So he must have been overwhelmed by that experience, and he continued working on neotropical birds for many years. He has written a book on the ecology and conservation of neotropical birds. He's been the co-describer of 6 new species of birds. So he enjoyed himself clearly in his work in Peru and the neotropics. He has also been the executive director of a field station, a very fascinating field station in Florida in the US called Archbold Biological Station, where he studied the Florida scrub jay. And those of you who are able to make it tomorrow morning, that he's going to be speaking about his Florida scrub jay work. It's an endangered species. Tomorrow morning at NCBS at 11:30. From there, he moved on to become the director of the Laboratory of Ornithology at Cornell University, and he's been there over 20 years now as director. And it's a fascinating place, the Laboratory of Ornithology. It's, as I again learned only yesterday, it's a not-for-profit organization embedded within a university, which allows great flexibility, I think, and also amazing amount of expertise to come in there, resources to come in, and the Lab of Ornithology does wonderful work in all facets of birds in ornithology, right? From pure research to conservation science to citizen science, and also just pure education and outreach about birds. And I think some of this work will be encapsulated today in Professor Fitzpatrick's talk. So without further ado, John.
Thank you very much, Suhail. I appreciate very much the energy that you've put in. I appreciate NCBS and NCF. Anthony, I appreciate your welcoming the group and to me, and Christ University hosting this amazing group. I'm absolutely delighted to learn about the Green Army, and congratulations to all of you members of the Army. As you'll see tonight, I believe in armies. They are accomplishing enormous amounts, and you're accomplishing enormous amounts as being one of the armies in India. It's been an enormous privilege for me to visit India for the first time. I'm 65 years old, and it's I will say an embarrassment that it's taken this long for me to get here, but thanks to Sahas Bharve, who's finished his PhD at Cornell just recently. Several years ago, I said to Sahas, I've got to get to India, and he said, yes, you have to get to India. So thanks to Sahas for helping make this happen and arranging an amazing trip. I believe firmly in what you see up here, and I hope over the next 50 minutes or an hour that you'll see what I mean by this maybe bizarre idea that the world needs saving, and birds have a chance of helping us do that. And by this, of course, you know that what I mean is the natural world. And everybody in this audience, you wouldn't be here if you didn't already know that the Earth, in its history, its 4.5 billion year history, the Earth is at a unique crossroads. It's at a cusp, a moment in time in which we have a choice. We, the managers of the Earth now at this point, have a choice of whether creatures like the great Indian bustard or the spoon-billed sandpiper, which are down to their last few hundred individuals, and whether the habitats and ecosystems in which they live, whether those get to persist for the next millennium, or whether in our failure to recognize the opportunities that we have at hand right now, we let them go for all time. That's a terrible cusp to be at, but we are here. And I'd like to hypothesize that it's possible to live side by side with natural systems. And I'd like to argue that we should not have to get to Antarctica to sit and watch the natural systems around us and have those systems watch us back. It should not be limited to a few very remote spots in the world. That should be a goal that we have for all of the world. We'll all be better off if we can do that. And so this idea that all cultures of the world can learn to live side by side with functioning natural systems, if that's going to be true, if we agree that that's a goal, then two very important things have to be true. Number one, all the cultures of the world are going to have to want that to be true. It's not going to happen by accident. It's going to happen because cultures learn and grow to appreciate that opportunity and want to keep it. And number two, and more importantly specifically for this talk tonight, we need a proxy. We need a way of measuring how we're doing, how close we're getting to that ideal of human cultures living side by side with nature in a stable way. And it won't come as a surprise to you that my conviction is that birds supply unique power to accomplish both of these things. So why is that true? A number of you here, I'm sure, know that that's true, trust that that's true, and are even using this already in your own work. But what is it about birds that gives them such power? Well, I'll suggest that at the minimum there are four very important features of birds that supply an unusual power to accomplish those two big goals that I talked about. Number one, they are and they've always have been remarkably effective tools for understanding how nature works. This can translate for many of you to basic research. Birds have for hundreds of years given us lessons about natural principles that are vital to all of natural sciences. And birds, because they're so accessible, are terrific tools for studying nature. They're also extremely sensitive environmental indicators. As bird populations change, they're almost always changing as a consequence of some feature of the ecosystem that is changing. And so they give us an alarm, they give us a barometer for how the change is going on, and perhaps alarming us and drawing our attention to what we need to attend to bring the system back to health. Number three, certainly important here in the Indian subcontinent, billions of birds migrate huge distances twice a year. Whether those distances are from the Arctic or Antarctic regions to the equatorial regions or beyond, or whether they're from the top of the mountain down to the bottoms of the mountains, or from the northern part of India to the southern part of India, billions of birds move twice a year with the annual cycle. And in this context, their movements and their numbers across space and time literally give us a look and a sense of the heartbeat of the annual cycle of Earth. And I will show you a few more slides what I mean by heartbeat. You will actually see before you the heartbeat, the pulse of planet Earth as expressed by birds. Finally, and absolutely vitally, and perhaps arguably most important of all, birds sing to us. They draw us into nature. Everybody loves birds. Every culture in the world reveres birds. They fly, they're beautiful, their songs draw us in. We don't need to know anything at all about birds, and we love them. So the birds have this unusual power to connect us, whether we know it or not, and whether we study it or not. They connect us with nature in a very unusual and aesthetically and spiritually powerful way. Put those four things together and you can see that there are no other entities on the planet that have this unique combination of powerful attributes that give us a chance to use those attributes for the greater purpose that I began the talk with, living side by side with functioning and stable natural systems. I like to illustrate the idea that you don't need to know anything about birds to appreciate them with a sound. We at the Cornell Lab, we have the world's largest library of natural sounds, the Macaulay Library. And I've chosen a sound for you to enjoy. So please enjoy. Can you hear it okay? Little jazz-like rhythm. I mean, who does not appreciate the idea that you can walk by a piece of woods and hear a little jazz tune coming out of the woods? Everybody in the world loves this fact about birds. We all want it to be true all the time, everywhere we go. How fortunate are we to have this? Now let me tell you what you're hearing. That's a sound given by one of these. These are the birds that the Polynesian emperors decorated their robes with when they arrived on the Hawaiian Islands about 1,500 years ago. Every one of the large Hawaiian islands had an o'o on it. And these birds were duetters. Male would sing, the female would respond, as many birds do. Male sing, female back. Beautiful duetters. By the turn of the 20th century, the early 1900s, 4 of the 5 o'os had already gone extinct, and what you just heard is the last of the o'os. The Kauai o'o was recorded in the Alakai swamp at the top of the island of Kauai. And what you just heard is in fact the last o'o. This is a bird that itself was believed to be extinct, and it was rediscovered in the 1970s up in the Alakai swamp. A couple of biologists got this amazing recording of them, and they played the recording back to the bird, drawing it in, and the bird was responding as if it was finding a mate. This was a male, and it was responding and waiting for the duet to return. So what you're hearing here is the last o'o. The last o'o. So let's hear it again. Hear him waiting for the response. We're never going to hear that sound again. That bird disappeared in 1988. It's now known to be gone, and so that all the o'os are gone. And that little difference inside you between when you first hear the lovely jazz tunes coming out of the forest and just be thankful that there's a bird out there. The difference between that and what you're feeling now, 1 minute later, where you hear this sound and you're realizing what it represents, what it tells us about our own choices, our past choices, our future choices, our opportunities in front of us, or the opportunities we've lost behind us. The difference between that 2-minute hearing of the species inside you illustrates the power that birds have to teach us something bigger than just the enjoyment we get from them. Lots of stories like the o'o. This is our version, the New World version. There is now an Old World version of this story with the curlews. The slender-billed curlew now, the Old World version, in this case the Eskimo curlew. This is a beautiful example of the Eskimo curlew taken a few years ago, but it's Cornell University's only specimen that happens to be mounted, so we put it in the grass so we could get a sense of what it might have been like. Because they're gone. We took them all. We took every last one of them. These curlews migrated by the tens of thousands up the central part of North America to breed in the Arctic. And by the end of the 1800s, they were being slaughtered mercilessly for food, shipped on rail cars to eastern United States cities to eat. And the market hunters that hunted these birds called them prairie pigeons because they reminded the hunters of the pigeon flocks that they used to hunt, but which were already gone. These pigeon flocks, you might know as passenger pigeons, these market hunters were killing the world's most abundant bird, and probably the most abundant bird that has ever lived on the planet. 5 billion passenger pigeons were occasionally documented as migrating in a single flock. And we took them all. As these flocks went by and as the breeding colonies established in the oak and beech forests of the north or in the oak forests of the southeast in the wintertime. We took every last one of them. The market hunters in the 1880s, when pictures were beginning to be taken like these, proud gentlemen showing the birds that you could buy to eat at the table. Only by this point they had just a very few in the lower right. There they are, a few passenger pigeons hanging from the post. All that was left of the billions that these gentlemen were hunting only a few years earlier. How could we do this? How could we take a bird as abundant as the passenger pigeon and bring it all the way down to zero in the course of only about 40 years? Supposing we'd had a gas gauge. Supposing there was a needle available in which people who were involved in this trade saw at some point, wow, we're down to half full, and only a few years later, whoa, we're down to a quarter full. Now we're down to only an eighth of a tank. Wait a minute, we ought to stop this for a while and let the tank fill back up. They didn't think that way. We didn't think that way. We didn't have the opportunity to actually watch and measure in detail what those numbers were and where they were going and where they were breeding from one year to the next. We simply couldn't see this remarkable range-wide phenomenon. As a consequence of that, they never thought about the idea that they might actually be disappearing. They simply breed one place one year, another place another year. They lost track. They never had track. Supposing they'd had track, would we still see flocks of passenger pigeons today? I believe so. Now, as I tell stories like this, it's important to ask the question, have we changed? Have we, the world, changed? Could we do this anymore? I want to tell a story about this amazing bird, the bar-tailed godwit, and other species like it that use the East Asian Australasian flyway from Australia, New Zealand, up to the Arctic to breed in Alaska and Siberia, but every one of those bar-tailed godwits stops, as you can see, in one spot, one region, the Yellow Sea, of coastal China and the Koreas. The place is really vital because they fill up the gas tank there so that they can get to the Arctic with a really full set of energy for the very fast breeding season that's in front of them. The Yellow Sea, filled with important, amazing places where these and 60 other species like them depend on in this trans-hemispheric migration. Here's a picture of one of these flocks of bar-tailed godwits. Amazing shot, amazing phenomenon where they're gathered there at these tidal mudflats that are filled with shrimps and worms that give them the energy to get to the next stop. I'm going to show you this entire picture now because it's an ominous feature to this picture. You see the cloud at the very, very top, the gray cloud. I'm going to show you now the full picture. That gray cloud is the dredging equipment and the dredging process that is systematically and rapidly filling in all of the tidal flats of the Yellow Sea to create commercial real estate along the coast of China and the two Koreas. The tidal flats that have fed for millions of years the migrations of millions of shorebirds that breed in the Arctic and winter in the South are being systematically destroyed. This is passenger pigeon all over again. Do we have a gas gauge? Let's see. Will we listen to the gas gauge if we have one? Bigger question. But we gotta have one. Now, I want to get back to Hawaii here because I want to illustrate sort of the opposite end of this story, that is endangered species and what they tell us. This is a story about Maui, East Maui, one of the bigger islands in Hawaii. And specifically, it's a story about what's going on under that cloud, which is almost always there. And under that cloud is this amazing wet, one of the wettest places on Earth. It's filled with tree ferns and mosses and liverworts and lobeliads of a wide variety of species. And in that forest existed a bunch of birds, including a number that were believed to be extinct by the 1950s and 60s, like the o'os, rediscovered. Amazingly, the akauhikohi on top, the Maui parrotbill on top, and the crested honeycreeper next to it, the EEV and the o'o. These are birds that were thought to be extinct, rediscovered. In the case of the lowest one, actually discovered for the first time in the early 1970s. As a consequence of this, attention was drawn to this windward slope of Maui, and a remarkable thing happened. A group of landowners, private and public, small and large, were brought together, Nature Conservancy being a major spearhead, brought together to create this East Maui Watershed Partnership, and now that entire windward slope of Maui is preserved, protected, and recovering, and the bird populations are coming back. Amazing. And why did this happen? Because of the birds. The power that birds have for galvanizing our attention and drawing our attention to things that we can actually fix. And I say fix advisedly because we've had to sometimes fix things that were genuinely disastrous. In the case of the U.S., the peregrine falcon is our most important symbol for this, as you probably know. In the 1950s and 60s, this bird was plummeting in its numbers, nearly extinct from the contiguous United States. And by the 1970s, it was now recognized that this bird was going extinct because of the fact that we were poisoning it with DDT and related pesticide compounds. In remarkably short order, the United States banned the use of DDT in the U.S. and did a few things to help the peregrine falcons breed and get going again. And within just a remarkably few years, the peregrine falcon populations recovered again and is now off the endangered species list. And their numbers now are arguably higher than they've ever been, or at least for the last 150 years. A very healthy breeding population again. We listened to what the birds were telling us. We changed, and they responded. This idea is paramount in our thinking about that ultimate goal that I began the talk with. That we, if we understand a change that we can make, that the birds will respond, the system will respond. And I'm talking about system because system is what it's about. In the United States, we have what I regard as the world's most powerful environmental legislation. It's called the Endangered Species Act. It basically says we will allow no species to go extinct if we can possibly help it. And the Endangered Species Act, of course, has a big list of species like this emblem of the act, the spotted owl, Western North America. But you should really be looking at this picture with this vantage point. That's the same owl, but the owl is actually now showing you its genuine scope and scale. It's just a tiny piece of the large ecosystem underneath it that was going away, that was being destroyed systematically in a variety of ways, such that the owl became endangered. The owl was a symbol of the system. And lest you mistrust my words, let me just take you to the actual words in the United States Endangered Species Act that define the act's purpose. Why did we pass such a revolutionary act? signed amazingly in 1973 by Richard Nixon. Not exactly one of our most favorite. Why did Nixon sign this? It says, or what did Nixon sign? Why he signed it is a different story, which is a neat story, but I just want to emphasize that in the act itself are these words. The purpose of the act is to preserve the ecosystem upon which these species depend. The Endangered Species Act is about preserving ecosystems. The species itself, the brown-eyed owl that makes us want to save it, is just the barometer, is just the lightning rod, is just the attention grabber for the system that needs our attention. So I now want for the rest of this talk to turn to a much more important story than deeply endangered or extinct species, namely all the ones that are left, which is most, right? In the case of the US, I'll come back a couple of different times to this bird. It's a thrush, the wood thrush. It's a very famous singer. It's many people's favorite song coming out of the eastern deciduous forests of North America. And the populations of wood thrushes over the past 50 years are telling us something very important. Keep in mind that this is still a common bird, but its populations have been steadily declining for the last 50 years. What is it telling us about the underlying ecosystem? It's not endangered. Does that mean we should not pay attention to it yet? Clearly, this is our chance to be paying attention to a species for what it's telling us before it disappears or becomes on the brink of being an OO. And in North America, there is a large number of species that are undergoing this kind of decline. I dare say this is almost certainly true in India. Once you have the numbers to test this across this subcontinent, probably you'll be seeing similar things. That there are a bunch of species that are showing a steady, inexorable population decline. Some of them, maybe many of them, despite the fact that there are places where they're protected and thriving. What are these birds telling us? And why is this happening, and what can we do to change this? The first and most important thing to do is simply to listen to them, to measure this, and make sure that we understand what they're telling us. There are species like this one, the common backyard bird called the northern flicker. It's one of our favorite woodpeckers in North America that are declining basically across their entire range. In the case of the flicker, this is a bird that lives and depends upon dead trees, as many woodpeckers do, not all, but many. And in North America, perhaps this is true in India as well, we hate dead trees. They're messy, they're dangerous, they're unsightly in our yards or in our forests. The foresters call them senile if they're dying and want to get rid of them. So dead trees are basically taken away. It's been true in Europe, by the way, for 1,000 years, which is why woodpeckers are so hard to see in Europe. Well, dead trees, it turns out, I'm a big proponent of the dead and dying. Good, healthy forests are filled with dead and dying things. Leave them that way. That's how they always have been, and whole suites of organisms have evolved to depend on the dead and dying organisms inside habitats. As it happens, I actually study, in a way, dead and dying. And I'm going to give a little diversion here to introduce you very briefly to the studies that I've been doing for the last 45 years in Florida. I've been a part of it for 45 years, and it has to do with this destructive influence. I was talking earlier with a few people about this destructive influence, this powerful feature of nature that when it happens often causes this powerful feature of nature, namely wildfire. And I study organisms that actually have a relationship with wildfire. Where you have lightning, you have ignition. And in the US, the peninsula of Florida, our only little hint of the subtropics in North America, is the lightning capital of the continent. There are more people killed in Florida every year by lightning than the rest of North America put together. one of the highest frequency lightning strike areas in the world. It's about 50 ground flashes per square mile per year. Where you have lightning, you're going to have some ignition. So you can see that the whole southeastern US is a place that has evolved in the presence of ignition for quite a long time. And in the process of thinking about this talk and this audience, I actually wanted to ask the question, what's the global map of lightning look like? There it is. There's one version of it at least. And I was struck by the fact that the rim of the Himalayas there is one of the darkest zones on this entire map. And I was just informed by Regina, I think, tonight, that Bhutan is called, what, Land of Thunder? The idea that that some elevations of the Himalayas are regularly struck with lightning makes me ask the question, were there habitats that were themselves actually so dependent, so responsive to lightning that they actually depend on it now? It's a really important unanswered question. In my mind, I'd love to know more about that. Back to my story, or our story in Florida. In the presence of this level of fire frequency, there have evolved several habitats. In particular, the one that I study is endemic to Florida, restricted to Florida, and grows only on these old sand dunes, and it's called the Florida oak scrub. It's a beautiful, mysterious elfin oak forest, basically. In its prime condition is little more than 1 meter or 2 high, filled with weird and rare plants and animals. And the flagship bird of this habitat is the only species of bird that's entirely limited to Florida. It's called the Florida scrub jay. It's the one that has been a subject of our long-term work, about which I'll talk more tomorrow at NCBS. And the Florida scrub jay is disappearing. It is now an endangered species. It's limited to the red spots that you see on this map. Apologies to the males here who are colorblind. 1 in 10 males have trouble with this slide. You can see it's very fragmented, limited to a few north-south ridges that are old sand dunes. And where we've been studying it is at the southern end of that central spike of red. At this beautiful place that Suhail mentioned, the Archbold Biological Station. And you're seeing the main building of Archbold here. And to the west, out there beyond it, is this low, open habitat that is the old, ancient Florida scrub. And in that scrub exist scrub jays that we've been studying for a long time, and we treat them very well, so well in fact that we get to study them at absurdly close range. This is my wife Molly with one of our study organisms on her head. She says hi to everybody. And in that vast area west of the main building that you saw, the main building in this picture is shown as the orange rectangle. West of that building, the scrub jays live in a mosaic of tightly interconnected and defended territories of about 10 to 20 hectares per territory, pretty big territories. And it's a completely contiguous mosaic out there, and every 6-digit code there refers to the name of a family in a territory. And inside those families are mated pairs of scrub jays that raise their kids every year. The kids actually don't leave home. They help mom and dad raise next year's babies. It's a cooperative breeding bird, much the way many of the babblers are here in India. And important to this story is the fact that in the 1970s and 80s, we were watching one of the populations of Florida scrub jays adjacent to Archbold go extinct. We were watching the population go down, down, down. And by the late 1980s, we had developed a hypothesis that there's something here related to fire. The habitat looked fine, it looked rich and beautiful, but the jays were disappearing. And we said, we think it has to do with fire. So we did what any good ecologist or any good scientist wants to do at some point. You conduct an experiment. And so we did. We burned it up. And I mean, we burned it crisp. We burned it to the ground, black. A big tract of scrub. And there's our postdoc at the time escaping his experiment, rapidly escaping his oncoming experiment. And what was the response? We predicted that the population would eventually begin to increase after this thing, and we were surprised by how quickly that actually took place. There's the response of this population. You could see what happened almost instantly. The population began to rebound, got to a saturated point kind of a high period point there. It actually stayed stable for several years. And then, and here's the key, it began to go down again. During this 20-year period, by the way, we kept it from burning. Our experiment included prohibiting fire for the next 20 years, or however many years it took to complete the experiment. And it turned out to be 20. Sure enough, little by little, the population began mimicking what it was doing in exactly the same place 20 years earlier. It turns out that for this species, there is a window of optimal condition about 8 to 10 years after a fire, and it's only a few years long, and ultimately it goes back down again. What does this tell us about the nature of the native habitat out there before humans were messing with the system? It tells us, obviously, that it had a natural fire cycle, that there wouldn't be jays there if this wasn't regularly burning. And not only that, it tells us about what that fire cycle is. It's about 8 to 15 years. And amazingly enough, a number of other organisms show the same pattern. So, by the way, we did, again, what we should do as conservation scientists. When it got down to that point in 2010, we said, what? Bingo! Burn it again! So there it is, June of 2010. The same place burning again. This is actually showing just post-fire where it's still the smoking ruins. Scrub jays don't burn up in fires. They simply watch and come right back in and forage in the smoldering ruins and defend those grounds. And sure enough, the population is again rebounding, and we expect to see that same period of optimal condition. Overall point here, the Florida scrub jay, now we understand it, by virtue of a long investment in the science of its fundamental biology, we understand that it is an indicator, not just of the presence of scrub, but of the presence of the processes that keep scrub environmentally healthy, natural, and fully diverse. And it's not just a story about scrub jays. There are dozens of plants and arthropods in the same system that are on the U.S. endangered species list and that have exactly the same stories. The consequence of this story from a land management standpoint, from a conservation standpoint, is burn it and they will live. Don't burn it and they won't. So the bigger point here, besides just the interesting fire ecology of a system and a piece of the world that regularly burns, is that the scrub jay indicates something to us. The point is, it's a barometer. If we manage a system where the scrub jay populations stay up at their healthy levels, then we're doing something right for hundreds or thousands of other things underneath it. The value of birds. And every ecosystem in the world, whether it's the American prairies that have meadowlarks and prairie chickens and various kinds of grouse, or habitats here in the Indian subcontinent that have great Indian busters or great Indian hornbills. Every habitat in the world has indicator species, and by following those indicators, we can understand much better than we've ever been able to do before how they're doing. How do we do that? Here's where you come in. Enter citizen science. Because in North America, we now know from every 5-year survey of the habits of adult adult U.S. citizens, how they interact with the outdoors. And it turns out that survey after survey, and these are big, extensive, multicultural surveys, tells us about the same thing. In the U.S., 70 million people self-describe themselves as at least casual bird watchers. 70 million people spend some time watching birds every year. Now, whether that number is actually 25 million, and maybe a few of them lie and so on, who cares? It's tens of millions. The Army. I believe in armies, and that is a good-sized army. And that is fundamentally why there's a Cornell Lab of Ornithology. We do a lot of things, but one of the central backbone elements of our mission, and here is our mission, Notice, by the way, that our mission statement, which is only 17 words long, we were talking about mission statements earlier this morning, 17 words long, and the mission statement very explicitly does not talk about birds until the last word. The mission, the active verbs and subjects of our mission have to do with the Earth's biological diversity. Interpreting with science, conserving with action, education. The Earth's biological diversity through research and education and citizen science, this amazing, weird thing that's emerging now in the 21st century, focused on birds. So very quickly, the Cornell Lab is a lot of things. It's 200 plus people, about 60 PhD scientists now at the lab. We do lots of different programs. I'm not going to talk about all of them here, but just to give you a quick look at the variety of things that we do. And for the rest of this talk, I'm really focusing on a nexus, a coming together over the last 10 years of a number of these different programs that have to do with digital resources and with citizen engagement. Our first step in this, as the internet came into being back in the 1990s, was to experiment with it as a teaching tool, showing the real lives, daily lives of birds, with how they get laid and hatched and they grow and so on, sometimes die with snakes coming in. Our lives really changed when we started going to live nest cams, which allowed people to watch the intimate lives as a day-to-day soap opera in the comings and goings of individual birds in nests like our famous barn owl cam, which was one of the very first high-definition bird cams. And this illustrates just a fun thing I want to mention, which is that we learned, and by the way, barn owl biologists learned from our camera, that barn owls do it every night. I don't need to get any more explicit than that, right? Every night, multiple times a night. They do it before the eggs are laid. They do it while they're incubating the eggs. They do it while the young are in the nest growing up. Right there. Male comes in with a mouse. They go at it. They enjoy it. This form of pair bond maintenance, let's call it that, they clearly love doing it, and barn owl biologists never knew that. So we're loving the fact now that we're learning, all of us are learning, including seasoned scientists, from the idea of going into the private lives of birds. Well, more quick, specifically to the point today, we experimented in the late 1990s with the idea that one of those birds I showed you earlier that's declining, the cerulean warbler, that beautiful light blue little warbler, we wanted to find out where they breed. Obviously, to save the bird, you need to understand where their main places of breeding are. We asked the question, can we get citizens to lead us to the important breeding spots for this bird? Indeed, we could. It turns out that we created a comprehensive map of every spot where the cerulean warbler breeds in North America, thanks to the efforts of citizens across the country. This was an oh my moment for many of us. We have a huge amount of power with this army. So we started also playing with the idea that we could ask the Army to watch birds and tell us what they were seeing. And so we invented, together with the National Audubon Society in 1997-98, this first idea, namely over a rather slow weekend in the middle of winter, middle of February, go out and watch birds and play with this really fun thing called the internet, and tell us what you saw. And in that, our first year, 14,000 checklists. So with 14,000 checklists over a course of a couple of days, it crashed Cornell University's computer system. Literally. 14,000, wow. Well, I think many of you are now active participants in Great Backyard Bird Count. Raise your hand if you've done one. Yeah, there's some of you, by the way, aren't raising your hand. Yeah, raise your hand if you participated in a Great Backyard Bird Count. Fabulous. Those of you who didn't raise your hand, you know who you are. So, as you know, we only several years ago, after working glitches out in the back end of this stuff, we decided it was try to take it global, and we did. And take a look at your mother country here. You guys, you rock. Almost instantly, you took part in huge numbers. The last year, numbers exceeded 160,000 checklists. We hope that that trajectory continues. I always say at the lab about lots of things, slope is not as important as trajectory. As long as this keeps going up, you're doing something right. Think that way about the Indian efforts here, and I think that you already are showing the world a huge example. I'll get back to that. I want to illustrate just one thing about the Great Backyard Bird Count that to me was personally life-changing. I'll put it in that strong a term. I'll do it by illustrating one species of birds, the one you know well. It's the Eurasian collared dove. But in the U.S., it came into North America in the late 1980s, began to spread across the southeastern U.S. And I just want to show you Great Backyard Bird Count maps for a few year period in a row about just with this one species. So we have 2005 shown there in a different sort of mapping, but here they come in sequence. 2006, 2007, focus on western U.S. and Canada, up in the northwest there. See the prairie suddenly beginning to fill in. 2008, California, boom, all up in the Pacific Northwest. 2009, getting very dense across the whole west. 2010, they're now abundant in the northern prairies in February. And by 2011, they were in Alaska in February. And there's the 2016 count. Now using an eBird back end for making the maps. My point, I want to go back to because it shows so well with these dots. My point here is not the biology of the dove, but although that's a very interesting story. My point is, look at how much information is in this one map for this one species for that 1 year. We have these maps in the case of North America for 415 species, and we have them since about the year 2000 in any numbers. Think about how much information that is gathered over a 4-day weekend in the middle of February. It's phenomenal what these are showing us about the natural world, including in cases like this, changes that are measured at the year-to-year basis. So obviously what came next was the natural outcome of this revolutionary, life-changing recognition of what the internet supplies us. And that is, why don't we do Great Backyard Bird Count every day? And let's call it eBird. And so, with a couple of different dead-end, premature experiments prior to it, in 2002, we launched what we still call today eBird. And as many of you know, because you're active participants in the third most active country in the world, you deserve an applause. What we commit to with eBird is very important, and I will dare say call it revolutionary from a biodiversity standpoint. Number one, we certainly commit to making it easy to gather data. It's an internet-based program that anybody around the world can use. It allows you to maintain your personal records, and it's hopefully an easy-to-use system that allows large-scale data gathering. Secondly, and highly importantly, we commit to archiving these forever. This is vital. Remember my question, supposing we had a gas gauge at the passenger pigeon. Well, we didn't. We do now. And so anybody, anytime from now until the end of time is going to be able to come back and watch populations of birds as a consequence of our commitment to archiving these data and making them available to anybody who wants to analyze them. Number 3, I just used the word, analyze. It's vital that we start diving in as the data accumulate to begin to ask the question, well, what are they telling us? Because just gathering data and not analyzing it is meaningless. So we commit to analyzing data and doing what we can to educate and train and partner with other individuals around the country and around the world in the process of understanding what these data are telling us. And there's so much data that there's room for everybody in terms of analysis of data. And finally, and ultimately most important, is converting what these data mean to actions on the ground. That is, partnering with conservation organizations, government organizations, and other NGOs in the process of identifying, prioritizing, and using these data to accomplish conservation action. One of the key strategies of eBird is that it is designed to do things that you want for your selfish purposes. I don't mean selfish in a derogatory way, I mean for your personal life. You can keep your records, you can play with your records as I did here with the sparrows as they come and go in my backyard, 4 species through the annual cycle. You can ask questions critically here. You can ask questions as I would if I had just a few more days here. Where can I go to see a forest owlet? Imagine if Pam Rasmussen had this opportunity. Well, as I did today, you can just pop into eBird and ask the question, not forever, but just for the last couple of years, where recently has the forest owlet been reported? And there's the answer. In eBird, there's the map, and the red dots are key, because if you're going to go try to find a rare bird that you've always wanted to see, you want to look at the red dots because those are recent. Somebody recently found this bird there. Well, what about the fact that they might have misidentified it? So you can ask questions about, well, did they take a picture of it? And the picture is, sure enough, there's one that has that little camera thing. Hey, is it? You tell me. eBird accomplishes things that people want for their own lives. And this recalls the conversation that we had again this morning. I think that Steve Kelling, I attribute this great accidental quote to one day in talking. He said, eBird began to be a successful citizen science project when it stopped trying to be a citizen science project. When it stopped trying to say, we want you to go out and gather some information for our project. But instead it said, turned that around and said, we want to do some things for you that you want to do with your habits and your hobbies and your desires for data. And as that began to happen, the volumes began to pick up. You can do trip planning, as you probably know. When you get to a spot, when you want to go to a spot, you can ask questions about a locality or a collection of localities and ask for the annual bar chart, see what's common there, what's not common. One of the most common questions that we get about eBird is, what do you do about data that you're not, there must be errors in that data. There's got to be uncertainties, got to be some things that are bogus. And as many of you know, because you are it, we have now a system of, I think the number is 1,800, but it's probably even higher than that at this point, worldwide editors. We also have built-in filters that you have to cross the first pass before an editor even sees the record. So there are various ways in advanced citizen science projects for building several different layers of filter that keep the most egregious reports, for example, of dog birds, and make sure that they're properly identified as catbirds. And we thank and tip our hats to every one of you, any one of you who is an eBird editor. We particularly tip our hat to Suhail, who's done a magnificent job of galvanizing and organizing and holding the tiger by the tail of Indian birding. And it's working worldwide. We're happy to say that the growth pace of the use of eBird continues to be an exponential curve, almost perfect exponential curve of about 30% annual growth annually. We're now receiving on the order of 400, varying with the month. The North American springs or the northern springs are the highest. Those are those annual peaks. 400 to 700,000 checklists monthly worldwide. That's a huge amount of information. I want to show you what it looks like on a otherwise blank map of Earth. This is not a map. This is just a place that we've put the dots on for eBird localities as of 2010. So you can see, obviously, given its history, its origins, and so on, North America is pretty strong. We began to have the Andes represented, a few other places, Europe a bit, New Zealand certainly. India starting to come into focus there, but the outlines of the country are still a little hazy. 2012, which was now 2 years after we actually did officially go global. Lots of progress in other parts of the world. India is beginning to emerge. I just want you to concentrate on and have fun with this contrast between 2012, which is so close you could almost touch it just a couple of years ago, 2012 and 2016. Congratulations. You can see the Indian subcontinent. You know, if you know mapping, that you can make a small number of dots look big by just making the dots large, but that's not true in this case. This is a real deal. There is emerging, and I want to come back to this in a second, and you'll see why. Emerging, I think, in this Indian subcontinent, and perhaps well up into at least southern China, opportunities here that are still to be taken advantage of. 25 million hours have been spent watching birds. I suppose there are those that would call that wasting time, but we know better. The real point here in the kind of last section of this talk is that we have now acknowledged that ornithology has joined climate sciences and ocean fluid dynamics in the realm of big data analysis. Because with now more than 300 million observations from all over the planet, and by the way, every country represented, and all but about 30 species of birds now have been reported on eBird. We have the opportunity to put the eBird observations together with land cover use information, with weather data on the individual counts, and with satellite coverages of a variety of kinds around the world, including productivity and so on, and crunching these in advanced algorithms with statistics, machine learning, and putting them through high-performance computational modeling in a way that allows us to do something nobody's ever done before, which is to see distributions of birds as they actually are in the world. And by that point, I want to illustrate with this bird, one of my favorite North American birds, prothonotary warbler. And in bird books, any source you go to, and this is true for India as well, you look at the range of any bird you pick, and it's what I refer to as a blob. There's the range, supposedly, according to one source, of the prothonotary warbler in eastern U.S. It's a big blob. You should be able to find this bird anywhere in that blob, in theory, right? We all know that's not true, but the range maps don't show that. I'm now show you what the actual breeding range of the prothonotary warbler looks like based on eBird modeling. It's anything but a blob. It's highly heterogeneous. It has places where the bird inside that other blob where it's completely absent, big places. It obviously has places where it's extremely common. And by the way, if you're interested in the conservation of the prothonotary warbler, or as prothonotary is a barometer of other habitats underneath it, you can see the places instantly where you'd want to pay attention. There's the range. And every bird species in the world, I would submit, has a range map that has this level of complexity to it. We've never seen them before in history. Now this is what bird books should be showing us, because this is the actual biology that matters for the birds. But this is just a snapshot. This is like a mashup of a 5-year pattern, actually, is what this map is. And this particular map is kind of old-fashioned now, because this map is actually occurrence, probability of occurrence. But that doesn't count. What we really want to know is abundance. There's where the rubber meets the road. U.S. expression, probably. And I'm going to show you now where we are today in terms of understanding Western Hemisphere birds. Because for every species of Western Hemisphere bird, we are now in the process of creating one of these. Namely, an animated map that shows every week of the year in a full annual cycle of, in this case, this beautiful magnolia warbler. Look at the spring migration up to its breeding grounds in extreme northern US and boreal Canada. And during the summer months, we're now at August. August begins to come back down, flowing down across the Florida Peninsula, across the Gulf, and down into that incredibly tiny wintering zone. Nobody really had appreciated how tiny the wintering zone of this one species is. Can you imagine conservation value for maps like this? What about and what this opportunity we have now with these data across the range and annual cycle of this bird, we can actually then look at maps of where the most important breeding spots are, where the most important wintering ground is, and where the most important migratory stopover places are for this one species. So we have the full annual cycle analyzable now as a consequence of this. Could we do this at the whole community level? Absolutely. And so what the next map you'll see is analogous to the magnolia warbler, but this is now for 20 species put together. And what you're going to see is dense species richness, the total number of overlapping species at any one point through the year. And you'll see that it shows much the same thing as that one species did. Namely, in the wintertime, it's now March, you see there's April, this one goes a little faster. Up to the breeding grounds, you see the high density of species in the U.S. Appalachians and up in the upper Midwest. And then in September, the movement back down across the West Indies, and then down to a remarkably small area where that entire community of species is concentrated in the wintertime. As a consequence of these maps, we at the Cornell Lab have actually initiated a major program of partnerships with institutions, local community organizations in that part of the Yucatan Peninsula to begin to engage them in monitoring both the migratory and the resident birds for purposes of conservation. We can calculate things like this. This is what we call the use days. This is a percent of the annual cycle for a given species. I believe this is for that same community of birds. The number of percent of the total annual cycle of these birds are spent in each of those grids. So we can start looking at amazing details about the biology of moving birds during their entire life. And now I want to get to what I regard what is clearly the sort of roadhead, because we have gotten to this point. We're beginning to do these maps for a wide variety of species and apply them little by little to some conservation questions. But the key question is, what does the time series tell us? Ultimately, we monitor birds like this year after year because we want to know what their trajectory is over time. Are they increasing? Are they declining? Are they stable? And where are they doing one or the other? And this map shows you that annual cycle of the wood thrush. Look at how tiny its wintering range is. Again, same pattern that you've just been seeing. There's its breeding ground. Again, remember, this is the bird I showed you earlier that's a steadily declining bird, at least by the several crude measurements that we'd had up to now. So we very recently went to work asking questions of the last 10 years of eBird data, doing all the complicated algorithms required to correct for the biases of years being different and the efforts being different and so on. Can we use eBird data to ask the question, is the wood thrush declining? Is it stable? Is it increasing? And what does that look like geographically? And here's the answer, and this is historic. It's unpublished. It's very recently off the press, and it's the only species for which we've done this so far, because it's not trivial. This, by the way, on the left is a map of the Breeding Bird Survey's estimates of range-wide increase blue or decrease red of the wood thrush over the past 20 years. You can see there's a lot of red. So Breeding Bird Survey suggests a lot of places where the bird is declining. eBird data suggests exactly the same thing. If you see any blue on that eBird map, point it out to me. the bird is declining across its entire range. And more ominously, the rate of decline, if you integrate across that northern area, is shown in the south. Namely, the rate of decline is, I believe that number translates to 2% annual decline every year. So we'll leave the wood thrush aside specifically. We'll talk about the general concept here importantly, because this does convince us that eBird data are actually usable as tools for measuring whether birds are declining and what the spatial arrangement of decline versus stability or increase looks like. One more fun animation I want to show you, and some of you no doubt have seen this already. It went sort of semi-viral when it first came out about half a year ago. You've seen the map of the magnolia warbler going up and down, and at any one day of that year, there's a center of gravity for that bird, right? There's one spot that would represent the geographic center for where magnolia warblers are. In this map, we have 120 species, where each blue dot is the geographic center for where that bird is, where those birds are, on a specific day, in this case, January 8th. And now what you're going to see is those 120 species go through their collective annual cycle, with each dot representing a different species. Here we go. By the end of January, there are already birds moving northward from the southern cone. By March, they're massively moving northward. April, across the Gulf of Mexico. May, they're coming into the breeding zones. Watch how quickly they change. June, July, they're already coming back. The breeding time in the Arctic is so short. Here they come back generally more eastward than they did on the way north, many of them coming right over the Atlantic to get down to South America, back down to their wintering zone, where at January 8th the cycle repeats. I'm just going to let it go one more time, because if you haven't seen this before, it's just plain mesmerizing to watch. Here they come north. Watch the ones heading way west to Alaska. Look at that one way up north at Baffin Island. That's probably purple sandpiper. Lots of birds coming right over the Atlantic. That's probably, could be mostly shorebirds, those Atlantic ones. There's one coming zooming right straight down. It doesn't blink an eye at the coast, heading back down. There's no end to the imagination of humans when you get into the opportunity for curiosity. Remember how birds are these great scientific tools for teaching us how nature works. Now I want to ask you the question, is it time for India to be thinking about doing this same stuff? Do you have enough data now? What would be required to get enough data if we don't? To begin to ask questions about birds like the pied cuckoo. So I just asked myself that question and said, what does the basic map look like? So the following two maps are the opposite ends of the annual cycle of pied cuckoo in India. This is summertime. I restricted my query to June and July, all years combined. So that's the aggregate map of the distribution of pied cuckoo in India. And I said, I think that's a pretty migratory species. So what does it look like at the opposite end of the year? And sure enough, there's the pied cuckoo as mapped by eBird in December to February, the dead of winter, where we are right now. Must be pied cuckoos around here right now. That shows me, you just saw the beautifully animated map of a North American species. I'm just going to guess that there's no reason why right now we can't begin to ask the question, can we do this for India? What are the resources required to begin to do this kind of mapping for the entire annual cycle for the Indian subcontinent, or even more importantly, for the entire Asian, or at least Southern Asian community? I think it would be very exciting to ask this question very specifically. India is one of the tech capitals of the planet. There is some high-tech requirement in this thing, but it would be really, really fun to work with you all to get that underway. I'll just close by saying we've begun to use these eBird data and the models specifically that come out of them for creating reports like our State of the Birds reports, in one case focusing on the public lands and how the distributions of birds talk about the responsibilities and opportunities of public agencies. And in this case, the 2013, focusing on private lands, working landscapes, ranches, farmlands, and forests. We've worked with the Nature Conservancy in California to use eBird modeling to specify opportunities for dynamic conservation, that is, identifying places in the Central Valley of California that are not within refuges, but where private landowners, if given the incentive, could change their behavior on rice fields such that those rice fields would become wintertime habitats for migratory birds. Overall, a really important point about eBird is to understand the fact that from our standpoint, this acknowledges that the common birds are the ones that are telling us the signals. Our job as conservation scientists is not just keep the rarest ones from going extinct, but it's actually to keep the common birds common, to keep the representative elements of abundance and pattern more or less stable. Only by doing that are we living genuinely side by side with a stable natural world. So in India, you have the same opportunity to be paying attention not just to the super rare, not just to the yellow-throated bulbuls, but to the birds that are right out your backyard, or right down the street, or in the patch that you might want to go to a little more frequently now because you can actually make a difference in understanding its annual cycle. And I would propose that this is an opportunity for us to have a brand new relationship with the planet, coming right back to my very first few sentences tonight. A new relationship with Earth, whereby spending just a few minutes, a few times during the month and the year, we can actually collectively create a system where the Earth's natural systems actually have an instantaneous feedback on how they're doing. Because birds are such good barometers, and because we enjoy them so much, and because they're such powerful motivators for people, whether or not they know a lot about them. This new relationship with the Earth, I think, has profound opportunity to change our trajectory. And I'll close tonight by showing you the place that I'm fortunate enough to be calling my home. This is my place. This is what I look out to from my deck, drinking a cup of coffee in the morning. This is what it looks like in the fall, as the leaves are changing in the deciduous woods. This is what it looks like right now. The birds change during those seasons, and it's fun to watch that happen. But I want you to not look at this and think, wow, that's Fitz's place. Close your eyes and look at your place. Every one of you has a place. Everybody in the world has a place that they love. Imagine the idea that we move towards a relationship in which people around the world invest in their place just a little bit by saying, what's here? Let's report that. Let's put the information together and let's see what it tells us. How are we doing? How are we doing at protecting this spot? This spot that is, of course, our origin. It's our home, and for many of us, it's our house of worship. By having and expressing and encouraging, promoting, and using this new relationship with the Earth, we are going to be able to figure out how we're going to live in the midst of all this grandeur. The most important message I have of all, for all of you, because you're all one way or another conservation bound, don't give up. Never give up. We can do it. Thank you very much. be happy to answer questions.
Thank you. Thanks very much. We're running a little over time, but I think there's time for a few questions if there are any.
Thanks a lot, Dr. Fitzpatrick. That's a very interesting talk. Can you give us an examples of how this kind of data has actually significantly influenced governmental policy, say in the US, for instance?
Yes, that's a really good, important question. Am I still on here? Can you hear me all right? We've begun to use this data in working particularly with federal agencies on management of areas in Western North America. There is, as you might know, significant controversy around the management of certain of the western habitats, non-forest habitats, that is sagebrush habitats, where a number of species are dependent and where rapid encroachment of the sage in really not very economically viable ways is reducing its viability. And so the Bureau of Land Management, for example, in the US, which manages most of the sagebrush, first of all, we can tell them, it turns out you own 3/4 of the sage grouse in the US, in their entire range. Your agency is responsible for the health and persistence of the species. They didn't know that. We can then break that down to their, whatever it is, 28 different subunits within the Bureau, and we can tell each subunit what they have and where they have it that's most important. And so those in turn have been used in the creation of locally tailored land management guidelines by the federal agency. So that's one example. And there are others like that. But so the basic idea is, where are they? How many are there? What places are most important? And what agency has the highest responsibility or opportunity, I like to say, to make a difference in the persistence of that bird. And obviously, that means how they treat the habitat, not just the bird.
So thank you, sir, for that absolutely delightful and inspiring talk. I just had this question regarding the fire.
Yes, the fire.
I wish I'm wrong and I hope I'm wrong. But you were giving us details about how this impacts in the span of say 20 years or 30 or 10 years. Yeah, that's something that I could figure out. But then how will it be if you look at it in the immensity of time, let's say in terms of centuries or millennia, will it still be the same sort of a result that we are likely to fetch, and how confident can we be in such a given context?
That's a good, I think I understand the question. And let me see if I'm answering the question you asked. Our job as managers of landscape, and by the way, critical to this bird, and to many birds, but this bird in particular, is areas of land habitat that are actively managed. And by actively managed, in this case, I mean specifically, we play God. We know that the original fire frequency was every 8 to 15 years. If we just say, let's wait for the lightning to do that, it won't happen. Because in the old days, prior to roads and citrus groves and housing development and so on, a spark here could cause a fire way over there. But that doesn't happen anymore. So without humans coming in and actually managing it for its native fire frequency, it wouldn't happen anymore. So we actually have to play a role in mimicking nature, the original nature. So I can be confident at a place like Archbold, which is almost 5,000 hectares, I can be confident that those hectares 100 years from now will continue to be experiencing the natural fire cycle, because Archbold is going to make sure that's true. And what we're trying to do is convince state park managers, Fish and Wildlife Service managers, refuge managers, and so on, to understand and execute in the same way. And so by that spreading of the word, provided that there are enough resources to do that management, because it's not cheap, we can be confident that because of the knowledge that we have, The humans on the ground will make sure that that's happening. Does that answer your question? More or less. I know I did extend a few things here, so I'm sure I went over. I appreciate your attention.
Professor, just wanted to take the question a little bit further. Now we have natural fires also happening, just as we have fires happening in California or in Australia. We have fires happening here also. But in these fires, we participate in terms of dousing the fires. So how do you see that, as to should we interfere into the natural, I don't know, happening, whatever is happening, or should we let it go?
In the case, a great question. And by the way, lest I be misinterpreted, many habitats around the world did have a natural relationship with fire. And in some of those habitats, the fire frequency now is too big, too many fires. Southern California may be an example of that. Australia may be an example of that. So my real point is our job is to figure out what, as best we can, what the original fire frequency was, and then do the best we can to mimic that. And in most cases, that means we're in charge. In the case of Archbold, which is a well-managed, medium-sized preserve, we put out most natural fires. We put them out, ironically, right? Because we actually want to be able to predict. First of all, having been director of that place for 7 years, I can tell you, for some reason, all these wildfires always happen on Friday afternoon. So you need to be able to have people to keep the fire within the confines of where you planned it to be. And so it's much more predictable. In fact, we use the term, as you might know, prescribed burning. It's literally burned by prescription. The wind has to be a certain direction, cannot exceed a certain number of miles per hour. The humidity cannot go below a certain number, and any of those situations that don't happen, we can't burn that day. So it's all done by plan to be safe and to be predictable in terms of its total extent. And my general sense is that except for the very, very largest preserves and parks in the world, like Alaska, and maybe one could argue Yellowstone in western U.S., some of those places, they do have a let it burn policy, but generally speaking, putting out the fires before they get enormous and out of control tends to be the best management. That emphasizes the point that we have to accept, which is, like it or not, we're in charge of this thing, this planet. Now, we've gotten that point, so we have to take seriously that job.
I think we have time for one last question.
Professor, thank you for the beautiful speech. Professor, I had a question. Since today we live in a massive sea of electromagnetic radiation, my question is that does EMR has a specific effect on the endangered species or birds in general?
I don't know. The shortest answer you'll ever get out of me. It's a very interesting question. We do know that birds migrate, that migratory birds use the magnetic field of the Earth in their guidance systems. They have a redundant guidance system, and one of the sources of data that they use for detecting where they're going and where they are is magnetic field. So to the extent that there are deviations in that come in unexpectedly, I suppose it's possible that they're occasionally influenced by that. Beyond that, it's outside of my scope, so it's a good question. Be interested to know the answer. So I appreciate once again all of you coming. You're a great audience, and bravo.